In this demo, I'll be showing the normal and bump mapping work and compare their visual effects. So the scene consists of two 3D fish models. The model on the left is using normal mapping, while the one on the right is using bump mapping. Both models are rendered with lighting and textures to enhance realism. So normal mapping is a technique used to create the illusion of surface detail without adding extra geometry. It works by using a normal map, which is a texture that stores surface normals in RGB values. These affect how light interacts with the surface, making it appear detailed even though the geometry remains unchanged. So, in the shader, I extracted the normal and the normal map transform into a world space using the TBN matrix and apply lighting calculations to create the depth detail. So, now the model on the right, which uses a bump mapping, it uses a height map instead of a normal map. It simulates surface height variations by adjusting normal based on the grayscale values of the texture. This method modifies lighting calculations to create the illusion of the depth. In the bump mapping shader, I sample the height map, compute the gradient, and modify the surface normal accordingly. This adds realistic depth effect, but it can sometimes produce less accurate shading than compared to the normal mapping. As you can see, the both techniques enhance surface details, but normal mapping generally provides a more realistic look, especially at sharper lighting angles. Bump mapping, while effective, can sometimes appear less detailed compared to normal mapping. Um, so to summarize, normal mapping is ideal for high quality real-time graphics, while bump mapping is simpler but can have some shading artifacts. This assignment demonstrates how shaders can enhance 3D models without increasing polygon count.